Okay, welcome back. So now let us discuss one more problem in our section of solids. As I told in my previous lecture, projection of solids is very important for this section of solids. So you try to look back into your projection of solids before you learn this section of solids. Okay, so let us see a problem here. The detailed problem is available in the description. A pentagonal pyramid of side 40 mm and height 100 mm. So this is what given in the problem, where it is resting with its base on HP, where the base edge is parallel to VP. So I want to make a very clear note in case of a parallel to VP. So see here, if the particular edge is parallel to VP, either I can draw my pentagon either in this method or the pentagon can be drawn in this method. Okay. So both are same. See here I am having my reference line. See, you can see this edge is parallel to my vertical plane, and similarly this edge is also parallel to my vertical plane. So in a single problem I am going to teach you a three concept here, where I am going to use this particular problem, this particular type in my problem. You can ask me why. Since it is not given that it is parallel to VP and nearer to it, and it can be given as it is parallel to VP and away from it. So what is the meaning here? So the particular edge which is parallel to VP, which is nearer to vertical plane. Here you can see the particular edge is parallel to vertical plane, which is away from vertical plane. So this is also one of the way where they can ask in your problem. Okay, so it is very important. So if at all there is a choice of question, the question may be available in this particular type also. So this is a simple question. Now let us come into our cutting plane. See, the cutting plane is perpendicular to VP and it is inclined at an angle of 35 degree to HP. Okay, and where it is cutting, bisecting the axis. So what is the meaning of bisecting the axis? See here, what is the height given? 100 mm. So for example, from the base, if it is 100 mm, if it is bisecting the axis, it is nothing but the midpoint of the axis. So it is very important. So as far as you know that I have drawn my simple position and I have marked my name A, B, C, D, E. I have found out the center point. Once I found out the center point, it is mandatory in pyramid to show my triangular faces, so that I have connected all the corners to O. First I have taken my center line, I marked 100 mm as my height. Then from here if I can see A, B, C, so that A is a darker slant edge, B to O is a darker slant edge, C to O is a darker slant edge. When I look from here, I couldn't see E and D, hence E dash to O dash is in a hidden line and similarly D dash to O dash is in a hidden line. Okay, so this is how I have been completed my simple position. Now let us try to draw our section view, for which what I am going to do is I am going to take a midpoint of this particular height. So let me take the midpoint. Okay, after taking the midpoint, I have to use my protector and I have to take a 35 mm. I have to take a 35 mm. So it is approximately here. So once I take, I can draw my section plane here. As I told earlier, how to draw the section plane, you should have a longer dash, you should have a shorter dash, you should have a longer dash, which is nothing but similar to that of a center line. Okay, but at the end it should be darkened. At the end it should be darkened. So now I hope you understood one more concept here, why this B to O is darker instead of a center line. Hence B and O comes in the same line. The concept is I have to show B to O. That is the reason why I have drawn like this. Okay, so then obviously I know that I have to draw a perpendicular line with the arrowhead, and I have to name it as a CP, which means that cutting plane. And you know that obviously only object which is below the knife, only the object which is below the knife should be darker. So that is the concept of your section of solids. So I am trying to draw this. So this is one point and this is my hidden line. Since it is available, it has not been removed. The top portion of this particular object is being removed since it is been cut off. Okay, so I already told you the concept. Next, you try to identify wherever the knife cutting. See here, the knife is cutting 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 here, and the knife is cutting here. So all are slant edges. So A dash to O dash, A dash to O dash, B dash to O dash, D dash to O dash, C dash to O dash. So everything is cutting only in a slant edge. So in order to name, you try to project all the points towards your top view of your slant edges. Then you try to complete the position. Then you can name it. See here. First I am trying to have from A dash to O dash. So this is my point. E dash to O dash. This is my point. Okay. And similarly see here D dash to O dash. This is my point. And I am having here C dash to O dash. This is my point. So now you may have a doubt. See here. This point which is available here is in a straight line where I couldn't even project it. So that is a one way. What you have to do is you draw a line. You kindly watch carefully. You draw a line towards your last slant edge. See here, I have projected this point which is available to B dash to O dash to C dash to O dash. Now you try to project this particular line towards C dash to O dash. The point which was available in B dash to O dash is transferred to C dash to O dash. Now again I have projected to C dash to O dash. Now you try to use your compass with the O as the center. You try to rotate it and you can have the point here. So this is how I have made this point towards my B dash to O dash. Okay, now you try to connect all the points. See here, I am trying to connect all the points. Okay, now I am trying to connect all the points. So don't forget to have all your okay. So this is how it is being completed. So hence the top portion will be removed. This entire part is being removed. So now I have to even hatch it. As I told you earlier, you should use a 45-degree line and you should have a uniform gap. Okay, so now I completed my hatching and I can name this as a sectional. This is my sectional top view. The ultimate aim of this particular section of solids is used to identify the true shape of the object. As I told in my previous lecture, to find out the true shape of the object, first you have to draw a line which is parallel to your cutting plane. So this cutting plane is called as an axillary cutting plane. It should be away from your front view or your top view. And I can name it as X and X dash. So this is the first step. So before which I forgot to give the name. See here, once it is completed, you can give a name 1, 2, 3, 4 and 5. You project the same name here. This is 1 dash. Okay, and this is 2 dash. This is 3 dash. This is 4 dash within the bracket, and this is 5 dash within the bracket. Okay, now what is the next step we have to do? We have to project all these points 1, 5, 2, 4, 3, which is perpendicular to my axillary cutting plane. For which what I am going to do is here I am going to have my scale perpendicular, and from each point I am trying to draw the lines. 1, 2, 3, 4, and finally I am having point number 5. Okay, you can see here, this is for point number 1. This is not required for your purpose, only for your understanding purpose I am writing here. 1, 5, 2, 4, 3. Okay, as I told in my previous lecture, what you have to do is, you have to measure to draw your true shape. If your cutting plane is in your front view, you have to measure it from your reference line towards your top view. See here, I am going to use my compass from reference line. This is the point number 1. From the same place, I am cutting an arc, which is my which is my point 1. And similarly, see here in my second line, I am measuring like this, and I am having this is my 5. Okay, from my reference line, I am measuring 2. From here, I am having a point which is called 2. So I will simply extend it, and here I am having my 2. And see here, in this particular point, I am using to measure this 4. From here, I am setting an arc. So where I am having a point number 4. So from here, I am measuring this particular 3. From here, I am giving it, and this is my particular thing. Okay, so I have measured all the points and I have been noted it. Now I need to connect all the points. See here, I will connect. This is 1, 2, 3, 4, 5, and again 1. Okay, so let me name it off. This is 1, this is 2, this is 3, this is 4, and this is 5, which is nothing but a true shape. Okay, so what I have to do finally, I have to hatch it in order to complete my true shape, for which I am using a 45-degree line. Okay, I am using a 45-degree. So here I am using my scale. You can use your set square, or you can use your protractor, and you can try to complete this particular problem. That's all. Okay, so this is our sectional, this is our elevation or front view, this is our sectional top view, and this is our true shape. So for it is, so that we have completed we have found out the true shape for a sectioned pentagonal pyramid. Thank you.